morning, one and all. The subject name is compiler design. In the previous session, we discussed about some of the concepts which are related to predictive parsing. So, in this lecture, some of the remaining concept about the predictive parsing while constructing the parse table, we are going to see the remaining things. Here, what is meant by predictive parsing, that is covered in the previous videos. We already know the structure of a parse tree and left parsing and top down and bottom up parsing and different types, that is recursive descent, non-recursive descent, and LR parsers. We are having set of types such as LR and CLR, LALR. These are the types which we will discuss coming sessions. First, predictive parsing. In predictive parsing, first and foremost one is, that is, we have to eliminate the productions which are not reachable. That means any unreachable productions are there, that is not to be considered while performing this predictive parsing table. And the second most important one is another one, ambiguity also can be verified. We know that ambiguity and unreachability in the previous sessions, and also any left recursions possibility verified, that can be also verified and then eliminate from the grammar, so that we can proceed to the next step, that is called as left factoring and first and follow, and then we are going to construct the parse table. This is the rules that is to be considered while constructing this parse table. First, that is, we verified and we eliminated unreachability, means that where the left hand and side null can be resolved with any of the terminals, non-terminals which are already available, that can be verified, then reached whether or not. Any such productions are there, that is to be verified. So, previous example, we have seen this type of productions where the unreachability occurs in some of the cases, that is where it is reachable, and G derives A, it is also reachable, A derives reachable, and this one. And this is not reachable. In the previous, we have seen this, why it is not reachable. This type of the grammar are to be eliminated. And final grammar, that is, this one is after removal, we are getting a grammar that is reachable productions. Unreachability is eliminated. And we have to verify the considerations of ambiguity by implementing the precedence, that is lower priority, higher priority, that is operators levels, either low levels or higher levels. And associativity also, we come across this one, that is left to right and right to left, and then we perform left recursion in the implementation. We have seen one example. This is to be verified with the corresponding. How to eliminate? By applying a simple formula, that is a rule, that is A derives beta A dash derives alpha A dash. Now quickly, now in this we are going to see that one more specific rule, that is, for example, if any derivation which contains of the form, that is this type of the form, such as A derives A alpha 1 or A alpha 2, that means this production A alpha 1 is one production, another production A derives A alpha 2, like that several productions, then A derives beta 1, A derives beta 2, so on. So, whenever the productions of this form, then that is to be replaced with this one, that is A derives beta 1 A dash and A derives beta 2 A dash, then A dash, which implies alpha 1 A dash, alpha 2 A dash, and then epsilon. Now, we have seen one example. This is that example to be considered. This is the general structure format where the syntax that is to be divided the productions of the form. And you see here in this example, the first production is S derives S6, and another production S derives SSB, and S derives XS, and S derives A. So if we observe these two format is the same as the type such as A derives. First one is A derives A alpha 1. That means here A derives A alpha 2, where A means here S derives Sx. So that's why A derives A alpha 1. Suppose in this case A derives A alpha 1. So this is the A alpha 2, and A derives beta 1, and here beta 1 is this one, here as the A derives beta 2. So in these cases we know that what is alpha 1, this is alpha 1, that is x, in this case alpha 2, and this entire, that is beta 1, and this come to be beta 2. Now if you apply the formulation, that is A derives beta 1 A dash, and A derives beta 2 A dash. Now if you apply this one, we will get A derives, what is beta 1, that is XS. A dash, so here A indicates that yes, this is A is yes. So in this case our formula, syntax generation, A is X. So that's why A derives beta 1. Beta 1 is XS. So we have written XS, and then we apply, A dash. A dash means S dash. And the second one, A derives, that is S derives beta 2. What is beta 2 here in this case? A. And A dash, S dash. So this is the formula. This is the syntax we applied for the first two cases. So another case, third one is third rule, that is A derives beta 1. A derives beta 1. Here in this, we are going to apply this here. What is A? Yes. What is A dash? A dash. Here we are going to apply A derives beta 1 for the two cases. We applied this first A, and then A dash we are going to get. That is A dash. So A dash derives alpha 1 A dash, and A dash derives alpha 2 A dash, and then A dash derives epsilon also. That is to be epsilon also one of the category to include in this step, in this one. Okay, these are the three. Now if we implement this rule for the second, that is A dash. What is A dash here? In this case, S dash. Alpha 1. What is alpha 1 here? X. And A dash. A dash means S dash. That is first. And the second one is, the second one, A dash means S dash, which derives the alpha, and second alpha 2. So here alpha 2 specifies, previous we applied alpha 2, now here SB. SB, and then what is the value of A? That is S, so S dash. SB, S dash. Now here in the third one, S dash epsilon. This third one. So we got the two rules for this one, and then we got this. Okay. Now, if you apply the syntax of the general form, and then we derived some rules. So that is the elimination. That's how we eliminated. And finally, in this we are going to combine these two into S derives. Why? Because left hand non-terminals are equal. So that's why we combined into 2x S dash and A S dash. And these three we combined. Why? Because S dash, X, S dash, and R symbol, then S, B, S dash, and then epsilon. So we got what? S dash and then S. So these are the S derives XS, non-terminal X, S dash, A small a capital S dash. That is one. And second one is capital S dash rise X S dash small s capital S small b capital S dash epsilon. So these two we are getting this. So if at all any derivation which is contains also, that is a alpha 1 and a alpha 2 we applied. Suppose if any derivation one more rule is also there, a alpha 3 so on, a alpha 4, we can implement these two with this one. And any derivation which contains a derives beta 1, beta 2, beta 3 also, then we can implement a dash. So in this way, we are going to eliminate left recursion. So here you see the non-terminal which is available is S, which is not is different from the differently available, that is right hand side of a combination of terminal and non-terminals. Hence, in this solution, left recursion does not exist. But in the given, that is in the given example, the where the terminal exists at the left hand side, and also the existence of the case for the first non-term first right hand side of the non-terminal first. So that in that case that is to be eliminated, and that eliminated grammar is to be used for the purpose of calculation of constructing the parse table. Hence this mechanism is to be used uh, to develop this predictive parsing algorithm, and that generation of the table to generate the output, the corresponding table grammar is the corresponding grammar is required. This grammar is requires the elimination of left recursion. So that is simply by applying the syntax of the format, such as A derives beta 1 A dash, A derives beta 2 A dash, so on, Bn A dash, and A dash derives alpha 1 A dash, alpha 2 A dash 1, and A dash epsilon. So here in the previous example video we discussed about left recursion, where it contains only limited number of steps, where the occurrences repetition of the cases where several A derives alpha 1, then we are going to implement this process. Sometimes the left recursion may exist indirectly also, then it is hence it is called as indirect left recursion. So we will see how the indirect left recursion exists in the for the given production. So here, if you see S derives A, capital A, small a, and S derives B, and capital A derives capital A, C, capital S, D, and then epsilon. So for these two cases, verify whether the grammar contains left recursion or not. So here we can say that a non-terminal S, it is left recursive because S derives capital A small a, and then capital A small a, and then it derives what is capital A. Capital A derives SD also. So here capital A which contains, so here if you consider S derives capital A small a and S derives small b, that is the two productions which are available from the according to the first. Whereas in the second case, the A derives capital A small c, that is one production. Another one is capital A derives capital S small d, and capital A derives epsilon. So based on this first rule, S derives capital A, and we are going to derive a rule such that capital A which contains capital S D. So we substituted and we got the result, that is S derives S D. So this exists at the non-terminal left hand side, and first most right hand side of the non-terminal. Then we can say that left recursion exists. This existence is called as it is not immediate left recursive. It is not immediate left recursive. So where immediate left recursive exists means capital X derives capital X, yes, then it is immediate. Where this type of production rule substitution and then deriving the one more rule getting this is not immediate left recursive, hence it is called as indirect left recursion. Hence it is called as indirect left recursion. So in the for the given production, in the given example, if you observe the cases, that is three cases, then A derives capital A C, capital A derives capital A D, and capital A derives B D, capital A derives epsilon. So here, after taking the first, second most, and the capital S, we substitute or capital A, we capital S D. Capital A derives capital S and then D. So here capital S is once again contains what? Capital A, small a. So that we applied and this indicates that capital A derives capital S D. And then capital A, small a. And we can also apply what? Small b also. Why? Because capital S derives small b. So capital A we can replace with capital A, then A derives epsilon. So in these cases, we are going to eliminate the immediate left recursion by applying this procedure such as A derives, that is A here in the case what? Yes, S derives capital A, small a, and then B. Whereas second one, beta 1 A dash, beta 2 A dash. What is beta 1 A dash? BD here. Beta 1 is BD, A dash, beta 2 A dash is epsilon. So that's why here A dash only. Whereas in the second case, alpha 1 A dash, alpha 2 A dash, small c A dash, and then alpha 2 small a d A dash, and then epsilon. So in this way we can apply the left recursion, immediate left recursion, where the existence of non-terminal is not directly defined, and then we can perform with the help of another substituting the non-terminal and get there is a chance of getting immediate this indirect. So that is to be also verified, and before performing this predictive parsing, this type of recursion also can be see the non-terminal which exists either not directly or indirectly of the cases. So that is not immediate left recursive. And another important point, that is the free from left factoring also. So what is meant by left factoring? It is another important feature of performing this predictive parsing, where this left factoring is useful for the transformations which are used in parsing. Whenever the productions which has more than one alternative with common prefixes, then it is necessary to make a right choice on the production. So performing the right choice, that means here there will be several alternatives, more than one alternative. That means several alternatives for the same production, for the non-terminal which exists for the particular substitution. So in this case, which of the production is to be considered? Say for example, A derives small b capital S, and capital A derives small a capital X. So the non-terminal exists the one small b capital S, non-terminal capital A derives capital X capital S. So we can get the results by applying first alternative. This is second alternative. That means two choices for building the parse tree. So which of the common prefixes may also available in some of the cases. That means capital S, small d, capital S, small a, capital A. So in this type of cases, common prefixes may also available. So at that time, we have to rewrite some of the productions which are suitable for this considerations. So that's why um, that's why we have to see the input, the existence of the string by backtracking our avoidance of backtracking by the parser. That means once the alternative has been chosen by the user, then the substitution may not give another alternative. It is the correct choice to the compiler point of view. So in this way, we are going to implement this left factoring elimination also. Consider the example A derives alpha b1 alpha beta 2. So here in this, the parser is not able to take the productions out of the given two productions. That might have to backtrace in some of the cases. So A derives alpha beta 1 is one factor that is to be considered. Another one, other choice as alpha beta 2 also to be considered. So this to be avoided. So this common factoring, left factoring, is to be eliminated with the help of the two substitution rules. That means the given grammar contains the production, then that is to be replaced with the two most productions, that is A derives alpha A dash and A dash derives beta 1 beta 2. A dash derives beta 1 beta 2. So in this case, parser will look ahead, always choose the right production. That is right production, that means to build the parse tree for the correctness of the given grammar. Compiler need not get the deviation of the results. So it should be in the correct format. So in that way, the verification of the grammar by implementing this left factoring, such as A derives alpha A dash derives beta 1, A dash derives beta 2. Suppose if the grammar contains a repetition of the several productions, that means for example A derives alpha beta 1 and one more production with the same repetition, that is left factoring, and like this one more production, this type of the repetitions alpha beta 3, alpha beta 4, like that so many cases exist, then for that format also we can apply for the two cases, such as replace this type of productions with A derives alpha A dash. This where factorings are available, that is to be considered as alpha and then A dash. But what is A dash? So this A dash is to be derived as beta 1, beta 2, beta 3, beta 4, beta 3 1, etc. So that is the two general syntax notations that is to be considered while implementing this left factoring. So here this is the two cases where the only two factors, two production rules are available. Simply replace with A dash, A derives alpha A dash, and then A dash is what? Beta 1 beta. So here what is to be considered? If the number of terms are increased, right hand side of non-terminals repeatedly occurring, where the process is to be generated several times, then in that case we applied the same, that is same factor first one, whereas in the second case we applied with beta 3, beta 4, 1, etc. So in this way we can eliminate left recursion and free from the grammar without left recursion, so that we can move ahead with the construction of the parse table. So why? Because if any uh, unreachability, not stopped, or ambiguity arises, then left recursion exists, left factoring also available. Then it is very difficult for the parser, or confliction of the results may occur, and then it doesn't lead to the good solution, and the output may not be correct. So that's why it is better to verify before constructing the predictive parsing table implementation. For example, for the previous general syntax rule, we can eliminate left recursion. So how the existence of left recursion takes place? So here if you see A derives capital A C, this is existing left refactoring. A derives capital A small d. So this to be avoided with the help of A derives. So in the previous we have seen A derives alpha A dash. This is the first rule. So what is alpha? That is first term. So here what is alpha beta 1, alpha beta 2. So the repetition where occurs, that is to be considered. So that is A. What is A dash? Here A. So here alpha is A only. So that's why we consider this one as alpha. And beta 1, beta 2 are this C, beta 1, and AD is beta 2. So A dash, what is A dash? We have to apply beta 1 and A dash beta 2. Only two terms. So here this is the general syntax. A derives alpha beta 1. So A derives alpha beta 1 means A derives capital A C. So this is alpha, beta 1 is C. And second one is A derives capital A, small d. So alpha is this one, A capital A, beta 2 is. Now if you apply A derives for this case, alpha. What is alpha here? A, capital A. And what is here? A dash. And what is A dash? Beta 1, beta 2. What is beta 1? Beta 1 is C, and beta 2 is A, small d. So these two are combinedly we can write A dash C, A D. And the first production is A dash, capital A dash. So we are getting these two production rules by implementing the left factoring the graph. And then we can, if it is a general format notation also, we can implement with different notations such as beta 1, beta 2, and then factors are to be increased. Several factors like beta 1, beta 2, swan, beta gamma also. We can extend this particular example, and then we can implement this. For example, another example which contains this left factoring notation, such as S derives. See here in this example, we have to, whether existence or not, then can be verified by this S derives capital small I, capital E, small t, S. So this is to be considered as alpha beta 1. And second one, S derives small I, capital E, small t, capital S, small e, S. Then in this case, we can write alpha beta 1, beta 2. So here IETS as alpha IET, and beta 2 is SES. So after replaced we will get A derives alpha A dash, and second one is, first one is A derives alpha A dash, second one is A dash. So what is A here? Capital S. And what is alpha? Alpha is IE capital E small t IETS alpha to consider. You can also consider IET. This one, this is what is beta 1? Beta 1 is not here. Empty. Beta 1 is so alpha, beta 2. So here alpha is IETS and A dash, S dash. And next S dash. Second syntax rule is A dash. That is beta 1, beta 2. What is beta 2? Here beta 2 is ES, beta 1 is only epsilon. So this is to be considered, and generation by applying the syntax of these tools, we are getting these two rules. And second one is another example. See, S dash small a, small a b, small a, small b, small c. That is A B C. And fourth rule is A B C D, and small e, small f. So in this one, we can easily observe that the left factoring exists with the combination of small a for these two cases and AB for this case, ABC for these three cases. So small a, AB for the two cases, ABC. If you observe, if you take this as separate, S derives small ABC, S derives ABC. So next, these two are. In this, we conclude that A, small a, which exists as a left factoring for the two cases, and in these two cases. For these two cases, we observe AB, and for these two cases, we observe ABC. So for this type of repetition of the occurs with the previous terminal with the second cases, then we can avoid this type of left recursion by implementing A derives alpha A dash derives beta 1 and beta 2 swan, etc. So for this case, what is capital S here? What is capital A derives alpha A dash. So here A is capital S and alpha is, for first consideration, we take small a, and A dash becomes S dash. And the last two terms we can keep, that is capital E, capital F, where this one is not as addition of the two rules, that is to be added almost. And where the S dash, that is to be derived once again. What is S dash? So here S dash is to be what is alpha. S dash derives beta 1, beta 2. So what is beta 1 here? Beta 1 is small b. Beta 1 is small b. So then beta 2 is not there. Then here we have to consider one again, S dash. What is here S dash? S dash is dash double dash. And then beta 2 epsilon. That is to be considered. And this S dash double dash once again to be repeated with this A dash derives beta 1. That means A derives alpha A dash. So here that's why once again double dash occurs. In the second case also S dash. That means S dash once again A, that is A derives alpha A dash. So in this case A is S dash and B S double dash we got. So suppose here in this case what is S? S double dash. So that's why. And what is this beta 1? That is alpha, that is C. And once again we'll get S triple dash. So S triple dash. Once again S triple dash, which is equal to what is here? D. And then God, that is here in this case epsilon. So in this way we are going to generate the grammar which is free from that means here what are the grammar that is generated, that is by applying this general syntax rule. A derives alpha A dash derives beta 1, beta 2, beta 1, and once again A dash beta 2. And by applying we get the notations such as the production rules are free. Observe the first one that contains S derives, where left factoring does not exist, and S derives S dash beta, where the non-terminal which is different from these two cases, and S double dash also it is different from the two cases. Here also different from the two cases. But either in the for the given the where the existence, that is factors are available with the two cases, that means S derives AB, ABC. So this type of the grammar also can be eliminated, and then this grammar is to be considered, and this is not contain grammar not contain left factory grammar contain, but this grammar contains left factory. This grammar contains left factory. So in order to do this from this to this, we applied these two rules. In order to get from this to this, we have to implement this two rules. That is, A derives alpha A dash derives beta 1, beta 2. But the alpha beta 1, beta 2 is alpha beta 1 may exist with where the different form notation. So we have to carefully verify. For example, in these cases where S dash exists forms with the AB different notation. So that is to be carefully observe and implement this, get rid of the solutions. And we come across this next point, that is out of the we have seen out of the important point. First one, unreachability. Second one, ambiguity of the grammar is required. And third one, left recursion and immediate left recursion. Those two cases we have taken as examples. And then fourth, left factoring are of the grammar. Just now we have seen with various examples how to eliminate left factoring. And the most important one is first and follow. After the grammar is free from the cases, free from these cases, then we have to construct the computations such as first and follow. So first is one computation and follow is another computation for the given grammar. First and follow, such as first and follow for the given productions. So this we will see as a separate topic in the next session, where this computation. After that, we can implement this parse table, where this parse table exists, and then we can develop this one and say that the predictive parsing table concluded for this. So in this way, we have to build a parse table mechanism before building verification of the grammar, to be carefully checked whether the indirect left recursion, left factoring, and then ambiguity, unreachability is there or not. That cases can be verified, and then finally we can say that the parse table exists. Parse table exists, but it should be in a corrective format where the predicted results are to be in the good enough to be carried out. Otherwise, it is not thoroughly checked, then we cannot say that the given parse table is to be correctly specified. In that way, this procedure is to be implemented with the computations. So, with this, we conclude that this parse table generations will be concluded. Next coming session with the computation first and follow, and then the generation of the parse table, continuation of this lecture. Okay, thank you once again, all of you. Thank you very much. And all the contents are to be available from the contents which are shown to be aware. The slides can be found out from the book that is called as Compilers Principal Techniques Tools, Alfred Sethi Ulpen, and you can find all these things. Okay, thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.